All right, IM2 classes. Today we're talking about factor by grouping. So we're going to be using that greatest common factor we talked about last time a lot. And after factor by grouping, we're going to be talking about what are commonly referred to as diamond problems. But let's get right into it. Factor by grouping. So what we're going to be doing is factoring this polynomial. If you notice the ones that we had yesterday, you had 2 terms or 3 terms, we're going to deal with something that has 4 terms. Right? And what you want to do is you're going to factor it by grouping. What we're going to do, step 1, group the first 2 terms and last 2 terms together. You group first 2 terms and last 2 terms here. And then you factor out a greatest common factor on each, just so we can see what's happening. I'm going to do some expanding here. 3, can leave that as just 3. And that'd be n times n times n minus 2 times n times n. That's the end of that one, plus 3 times n minus 2. So here, just like we did with the greatest common factor, take out what they have in common. So we can see here in this first group, I can take out 2 n's from each term. And so that's going to be n squared on the outside there. On this second group, this one's a little tricky. They don't have anything in common, a 3 and a 2. But what we want to do if they don't have anything in common, we're going to say we can multiply both these by 1, right? And then we're going to take out a 1 that they have in common. Right, so if they don't have anything, we're going to take out a 1 that they would have in common. And then what we do is we regroup things. So on the outside, I'll keep this green. So on the outside, I have n squared and then a plus 1. Actually, let me back up a second. Let me rewrite it before it's all, because that's all messy. So here I have n squared, and then there'll be a 3n minus 2 left here. Plus, I factored out a 1, and there's a 3n minus 2. What I want you to notice is that what is left after we found the greatest common factor, 3n minus 2 and 3n minus 2, those should be identical. If they are not identical, you did something wrong or it does not factor. For the problems I'm going to give you, you did something wrong. You need to go back and double check the greatest common factor here. These 2 that are together must be identical. And then what we're going to do is we're going to group those outside terms together. So n squared plus 1 are going to come together in their own group. And then this part that is here, we're just going to write it, and you only do it once. So this is like if we're multiplying, we're doing the split and distribute in reverse. So if you remember the split and distribute, we would take this, split it up. It's the split and distribute in reverse. So this here is the final answer. Let's do another example. 9n, yeah, this is a good one. So again, you group the first 2 terms together, the last 2 terms together. I'm going to expand some things. So 9 is 3 times 3, n times n times n. 3, it's fine just here, times n times n. Plus the 6 is 2 times 3. And I have the n. And for this one here, the 2, I'll talk about what we're going to do with that in a second. But let's go through and look for the greatest common factor here. So on this one, they each share a 3 in common. So I can take out a 3. And then they each share a 2n. So I have n squared, n times n. I can take out 2n from both. So n squared. Here's the deal with this, though. We need to mention when we take everything out of 1, and we did this on the greatest common factor, What we're going to do is say there's still a 1 left in there. So it's like there's a times 1 left in there. And we're actually going to do the same thing on this one, a times 1. If you look at this one here, again, they share a 2 in common, so I can take out a 2, and this way there's that 1 left there. So now let's go through here. So I have 3n squared times, there's a 3 and an n left in there, plus 1. So when you take everything out, you have that plus 1, and then there's plus 2 times 3n plus 1. And now I can regroup. So you group the outside terms together, 3n squared plus 2, and 3n plus 1. So group the first two terms together, do a GCF, a greatest common factor, on both of them, and then regroup. And that is it. We're going to move on to the diamond problems now. So the diamond problems, this is going to help us with the stuff that we're doing tomorrow where we're factoring trinomials, but we're going to practice it today. So the diamond problems, the top, so we have these x factors, we have two numbers. The goal of this is to find numbers to put in the side, and there's a pattern here. This number on top is a product, so meaning we have to multiply to get there, and this number on bottom is a sum. So the goal of these diamond problems is kind of like a puzzle, is to find two numbers that multiply to get 20 and then add to get 9. Some kids are really good at this and can get it off their head in their head really quick. Some need to make a list. So what I do, if it doesn't come to you, you can make a list. So list out the numbers that multiply to get 20. So 20 would be 1 times 20, or it's 2 times 10. 3, can't multiply anything by 3. You can do 4 times 5. 5 and 4 would be the same. And then that's going to be it. Those are our 3 pairs of numbers that multiply to get 20. And then which one of these pairs adds to get 9? Be this one here. So 4 times 5 is 9. So the answer is 4 and 5. All right. So let's do another one when there's some negatives. So 44 and negative 15. 44 and negative 15. So remember, the top is a product. The bottom is a sum. We want two numbers to fill in the sides that multiply to get the top, add to get the bottom. So for 44, the pairs that multiply to get 44 would be 1 and 44. 2 times 22. 4 times 11. 5 doesn't, 6 doesn't, divide it, 7. We can go, I think this is going to be it though. So 4 times 11, that is 15, but we need to be negative 15. So how do we get that? These both need to be negative. All right. So if we do this, negative 4 plus negative 11, that comes out to negative 15. But a negative 4 times a negative 11, a negative times a negative is a positive. So we can have negatives in here. And then let's do one example where only one of them size can be negative. So again, the top is a product. The bottom is a sum. So we need numbers that multiply to get 21. So it'd be 1 and 21. But here's the deal. It needs to be a negative 21. One of them has to be negative. So it could be negative 1 and positive 21, or it can be positive 1, negative 21. Neither of those add up to 4. The other pair of numbers that multiplies to get 21, that's easy. That's just going to be 3 and 7. So one of them has to be negative. So it can be negative 3 and positive 7, or it can be positive 3, negative 7. Which of these are going to add up to negative 4? That's going to be this bottom one here. 3 plus negative 7 is negative 4. Our numbers on the side are 3 and negative 7. With the diamond problems, it is literally a guess and check. So find numbers that multiply to get the top and check to see if they get the bottom. It's all guess and check. So we're going to be practicing those a lot the next few days. And that will do it. We'll see you guys next time. We're talking about factoring trinomials.